area approximation. We have seen how we can calculate areas of regular shapes. For example, area of a rectangle is equal to length times width. Area of a triangle is equal to a half base times height, or a half AB sine theta, or you can use Hero's formula. Area of a circle is equal to pi r squared. So when the shapes are regular, we can use the formula to calculate their areas. However, for irregular figures, it is difficult to obtain their exact areas. Consequently, their areas are approximated using various approximation methods. For example, we can use the counting method where we draw grids, square grids on the irregular shapes. We can also approximate these areas, and especially areas under curves, using methods such as the trapezoidal rule, mid-ordinate rule, and integration method, which are discussed in details below. When we talk about using square grids to estimate areas of irregular shapes, let us consider the following. Example: we have an irregular shape, the yellow shape in color. So to approximate the area, we draw square grids. Assume each grid is 1 square unit. So this is 1 unit, 1 unit, as dimensions of each square grid. So we count the number of full squares. That is 1, 2, 3, 4, 5, 6. So the number of complete squares or full squares is equal to 6 times the area of 1 square, which gives us 6 square units. Next, we count all incomplete squares and we assume each incomplete square is equivalent to a half the area of a full square. So the number of incomplete squares we shall have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So the number of incomplete squares in our case are 17. times a half square units, and that gives us 8.5 square units. So the total area approximate area of this shape is equal to 6 plus 8.5 square units, and that gives us 14.5 square units as the approximate area of this particular irregular shape. For areas under graphs, we have already mentioned that if the area is under a nonlinear graph, we can approximate this area by using rectangular bars or trapezia, and then using formula of getting area of rectangle and area of trapezium to approximate the required area. Consider area under the blue curve. So for this part A, this is our y-axis. This is the x-axis. So for part A, we can approximate the area under the curve, bounded by the curve, the line x is equal to A and the line x is equal to B, by dividing this area into rectangular shapes where each rectangle has a width of h. So they have equal widths. So because rectangles are regular shaped, we can approximate this area by adding the individual areas of the rectangles, and this is what we call the mid-ordinate rule. We shall see it in details below. Alternatively, the area can be divided into trapezia, where we have the first trapezia, the second, the third, and the fourth trapezia. In this case too, each will have uniform width. Then we can calculate or estimate this area, the area under the curve, the line x is equal to A and x is equal to B, by adding the areas of each trapezia, that is 1, 2, 3, and 4, so that we get the area under the curve, which we can, so the area that we are talking about is the shaded area. that is area under the curve, the x-axis and the lines x is equal to A and x is equal to B.